Okay, so we're going to do our first set of flipped notes. So just a reminder about this. As you're watching this video, you can speed it up or slow it down by using that function in YouTube. You can also pause it and come back later if you want. You can pause it so as you're writing stuff down, you have time. You can take breaks. Do what you have to. Just make sure you watch the notes. And if you have questions, please make sure you ask in class. Okay, so last few days we've been talking about scientific inquiry. Remember, the process starts by having a question, a problem to solve. We write that as a question, then we hypothesize and predict, test our hypothesis, analyze those results after we do our experiments, draw our conclusions, repeat, and then we will report what we have found. So now the next few pages in here, so as again, follow along with your notes just like you would in class. So the next couple slides just talk about each of those steps in a little bit more detail. So step number 1 is, of course, asking questions or stating the problem. We can't learn anything new unless we ask a question. Usually this starts with an observation. Okay, so an observation is just gathering information from our environment, and that can be a smell or a sight or a sound. And if you think about it, usually when you make an observation, it brings up a question. You can say, oh, what's that sound? Okay, but right there, that's a problem that you have to solve. All right, so observations lead to questions. What's that sound? What's that smell? What's that noise? Okay, those are all things that lead to questions, which then we want to solve. Usually we make an inference about that. So an inference is kind of like a hypothesis. Once you make an observation, you automatically come to this inference part, and you start hypothesizing what is going on in the situation. So inference sort of leads to your hypothesis. And as we've said in class, your hypothesis is a possible explanation about an observation that can be tested and used. Okay. We've talked about it. A hypothesis is an educated guess, or it's a prediction about what is going on in the situation. Okay, so we use our prior knowledge to make a hypothesis. Remember, you know lots of stuff, and the hypothesis is based off of what you already know. You can see I put a star by this. Okay, don't forget to do that in your notes. Those 2 words that we talked about in class, in your hypothesis when you're writing it out, we should always have if and then. Okay, if this happens, if we do this, then this will happen. Okay, if I double knot my shoes, then they won't come untied. All right. So following this step, then we have step number 3, which is testing your hypothesis. Remember, this is your experiment. Okay, a few things to understand about your hypothesis. There are variables in your experiment. Okay, so make sure you try to add these little notes into there. Okay, so the variables, that's kind of what your experiment is testing. This is what you're looking for. This is your data. Okay, that's what one of the variables, that's a decent way to look at what a variable is. So in our reaction time lab, one of the variables is how fast you can catch the meter stick. Okay, then you get data from that. You measure how far the meter stick falls, and that gives you your data. Okay, that's a variable. Another variable would be which hand you're using, dominant and non-dominant. Okay. Now, when we talk about something called a control is, there's different ways to think about it, but one of the best ways to think about it is controls are things that you keep the same. Okay, so in our reaction time lab, some things that we controlled were how we did the test. Okay, we did the test the exact same way for everybody. So that's why it stays the same. Okay, you want to make sure you're controlling as many variables as possible in a scientific experiment. You want the experiment to be the same every single time. That's a very important part of testing your hypothesis. Up next, number 4, analyze results. So after you do your experiment, you're collecting all this data, then you have to try to look at it and see what it means. You want to understand what does that data mean. Um, and one part of that is making sure we have comparable data. Remember, in our experiment, we're coming up with averages, which allows us to look at the data in a comparable single way. That's important because that makes it easier to, number 5, draw our conclusions. If we have clear data that we understand, then it's easier to make clear conclusions about that data. And then we can decide if it supports our hypothesis or not. Now remember, if our hypothesis is supported, then we want to repeat that hypothesis several times to confirm it. Okay, it's important to repeat tests to make sure that you get the same results over and over and over again, or at least similar results. And if it's not supported, that means you would modify and revise your hypothesis. Remember, in science, you're not wrong if your hypothesis is not supported. It just means you learned something else. So these are very important steps. Okay, your hypothesis is either supported or it is not. After you've finished your experiment and repeated it several times, then you can communicate your results and report that to other people. Scientists, this is a very important part of science because the scientific community likes to check and learn about new findings, and then other scientists would want to repeat this experiment as well. Okay, so science happens all the time, and there are things that result from it. Okay, so for this part, I'm actually going to start down here at the bottom. So possible explanations. A lot of times, science works this way, where something new is discovered, and it's just an explanation of something. Okay, it's an explanation of something. So, for example, a long time ago, Sir Isaac Newton figured out what gravity was, and he was able to explain it. Okay, from there, that didn't like change the course of Earth immediately, but it increased the understanding of things. Okay, a lot of times new discoveries in science are just explanations of things that we don't understand. And then it just helps us learn stuff, and it helps us to have better understanding of our world around us. Now, after these explanations are there, then usually that explanation can lead to something else. And one of the things it can lead to is a new material. Okay, new materials have been created because of science, and a lot of times they come from an explanation that was already made. So these new materials change the way we live. Okay, we have a couple of examples on here: silicon, clothing, metals. Okay, for a long time in human life, we weren't very good at using metal. Once we figured that out, it changed our life completely. Think of all the things around us now that are made of metal. Okay, clothing. There's a lot of clothing that we wear now that is called synthetic, or it's man-made clothing. That changed because before that, all of our clothing was made of cotton or wool. That's pretty much it. Those are the only choices we had. So now clothing has changed, so we have a lot of different textures and materials. Silicon has been an incredibly important new material that has been discovered. Silicon is used to make computer chips. So the computer chips in your Chromebook, in your cell phones, that stuff comes from silicon. It's a very good conductor. It makes those things possible. So after we have these new materials, then that usually leads to something called technology. Okay, technology is just the practical use of scientific knowledge. So usually science, it takes a while before it becomes technology. Technology is just anything new. So we usually think of technology as electronics. Okay, but transportation is a very important part of technology that's changed our life. Okay, think about it. Just like 150 years ago, the only way to get around was on a horse. Now we have cars and planes, trains. Okay, all of those things make our life so much easier. Okay, so science usually starts out with an explanation of something, and that can lead to materials that change the way we do things, which then leads to technology. Technology is how science impacts our life directly. Okay, now scientists often their discoveries lead to different things. So a scientific theory is an explanation of observations or events based on knowledge gained from many observations over time. Okay, so a scientific theory is something that basically it cannot be proven to be true or not true. Okay, maybe you've heard of something called the Big Bang Theory. Yes, I know it's a TV show, but the Big Bang Theory is actually an idea of how the universe started. It's the idea that the universe started from one tiny little speck, and then there was a big explosion, and all of the matter in the universe came from that. Okay, so that's an idea, and some scientists really believe it, and some scientists don't. But no matter what, that theory right now is impossible to prove because it can't be recreated. They can't make another Big Bang, and they can't go back in time to see the Big Bang. So that is a theory. It can't be proven or not proven. Okay, it's been supported by data and lots of investigations, but as of now, it's just a theory. A theory is different than a law. Okay, a law is a pattern that is always true. It's been supported by lots and lots of data. It's been supported by lots of experiments, and it is pretty much always true. Like the little picture I have over here, that's Sir Isaac Newton, and it says gravity, it's not just a good idea, it's the law. Okay, that's why it's called the law of gravity, because gravity always happens. Okay, it always happens. It happens on Earth, it happens on the moon, it happens on Jupiter. Gravity always happens. So a law is something that cannot be proven true or false, but no, excuse me, I said that wrong. A theory is something that cannot be proven true or false, but a law is always true. Okay, it's good to understand the difference there. Okay, last little bit here. Sometimes media can make it unclear whether or not science is truthful or accurate or not. And it's good to question things. Scientists question things. It's important that you question things also. But the thing about science is that science is based only on the data that they have. Okay, so science is based only on the data that they have and they have collected. It's not opinion based or anything else. In fact, science tries to really hard to reduce opinions and that type of thing. Okay. So this next slide, there's a lot of writing on it. So hopefully you have some information on these items. If you need to pause to write this stuff down, please do that. Okay, please do that. Make sure you have this information down. So critical thinking is a part of science, and that's where you compare what you already know with what you are given. And then you have to decide on what is right. Okay, so again, science isn't based off of opinions, it's based off of collection of data and what they see. So it's important to understand that there's a lot of different ways to collect data. One of them is sampling. Okay, so sampling is a data collection where you take a small amount of something to understand a bigger piece of it. Okay, you can assume that if you eat one slice of pizza, that the rest of the pizza is going to taste the same. Okay, that's sampling. Right? Scientists do this all the time. They can't sample every tree in a forest. So they will sample a small amount of them and then use that information to understand the rest of the forest. Okay. A bias. Okay, a bias is an intentional or unintentional prejudice toward a certain outcome. It's really important that science reduces bias. Okay, because if you want a certain outcome to be true, then it's more likely that that outcome will come true when you're collecting your data. So you have to reduce bias. So one way to do that is by not letting test subjects know what they're doing. So if we were doing a taste test on pop, and we wanted to find out if people like Coke or Pepsi better. Now, some people really like Coke, some people really like Pepsi. So if you put those cups, or if you put those pops in different cups and didn't label them, then they would have to actually taste them and see which one they like. That gets rid of bias. That type of test is called a blind study. It's when the subject doesn't know what they're sampling. Whenever you're doing a subject or a test that involves humans, a blind study is usually really, really a good way to go about it. Finally, we have repetition. Okay, repetition is very important. It helps to reduce errors. It helps to reduce bias. That's why I remember when we did um, our lab on reaction time, we tested everybody 5 times. Okay, scientists would aim to do that in all of their experiments. More repetition is better. It helps the data become more valid and supported. Okay, final thing for NOS 1, science cannot answer all questions. Okay, science can't answer questions about personal beliefs and values, and it can't because there's no data that can be collected on there. Okay, like an opinion is an example of a question that can't be answered by science. Okay, like what is your favorite pop? Science can't answer that question because that's your opinion. Science can't make something be your favorite. It just understands what you like, or it can collect data on it and go on from there. Okay, so that's an important part of science. And then safety in science is important. Um, Whether we're doing labs or whatever have you, doing things safely and by the right procedure is an important part of that. Okay, so once again, you can go back to this video, you can rewatch it, you can pause it, speed it up, do what you need to. Just make sure you follow along with your notes and watch this video. All right, thank you.